Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. This will be part 1 on closed-loop hydraulic systems, sometimes known as hydrostatic drives. Let's get right into the functional features of this type of hydraulic system. Instead of a directional control valve to change the direction of rotation of the hydraulic motor, and instead of a variable orifice for changing the speed of the motor, a hydrostatic drive uses a displacement controller, or stroker, attached to the piston pump's swash plate. The basic function of the displacement controller was covered in a previous video. Moving the control lever forward signals the pump displacement controller, which sets the swash plate angle to displace fluid from the upper A port. The fluid is delivered to the motor, and the motor begins to turn. Continuing to push the lever forward increases the swash plate angle, resulting in greater fluid displacement, and the motor turns even faster. Notice that unlike a typical open-loop hydraulic system, fluid from the motor does not return to tank. Fluid from the motor flows straight back to the pump. You would be quite correct to see the potential for overheating the hydraulic oil in this type of system. Notice that on the high pressure side of the loop, the hot oil shuttle has been shuttled or piloted downward. Some of the oil returning from the motor to pump is diverted through the hot oil shuttle and the hot oil relief valve back to tank for cooling. In this example, the hot oil is also used to flush and lubricate the working parts of the hydrostatic pump case. The fixed displacement charge pump, sometimes called a replenishment pump, is a smaller pump inside the main hydrostatic pump case. This pump draws fluid from the tank, replacing losses at the hot oil shuttle. This pump also pressurizes the inlet port of the main hydrostatic pump. Oil from the charge pump enters the loop through one of two makeup check valves. It is always the check valve on the lower pressure return side of the loop that opens to allow charge flow into the closed loop. In an open loop hydraulic system, a long inlet hose would be a cavitation disaster. In a hydrostatic system, it works out just fine because of the positive pressure on the inlet side created by the charge pump circuit. When the control lever is moved over center to reverse the direction of the hydraulic motor, the hot oil shuttle is now piloted upward to bleed oil for cooling from the return side of the loop that is now along the top of the diagram. It is now the upper makeup check valve where charge pump fluid enters the loop. Let's review the basics of the hydrostatic drive. Pump feeds the hydraulic motor. Oil leaving the motor goes straight back to the pump. The hot oil shuttle bleeds approximately 10% of the system flow back to tank for cooling. The charge pump and the check valves make up for losses from any case drains and also from the hot oil shuttle. At the very least, a hydrostatic drive uses cross-port relief valves to protect the system from excessive pressures. In the next video, we will cover pressure control valves in hydrostatic loops and look more deeply into the charge or replenishment system. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at LunchboxSessions.com.